Hello, everyone. My name is Meghan Goodchild. I'm the Research Data Management Librarian at Queen's University and at Borealis. I'm a first-time attendee, so thanks so much for everyone being so welcoming. Such a wonderful conference. I'm really delighted to be here to share some behind-the-scenes work that we've been doing at Borealis in relation to research data preservation. And my co-author is Julie Shee, who is the Digital Preservation Librarian at Scholars Portal. So to give some context, of course, start with a definition of research data management, or RDM. It really concerns the practices applied throughout the research lifecycle that guides the planning, collection, documentation, storage, sharing, and preservation of research data. And today, really, I'll be focusing on the latter stages. So really when data are deposited into a research data repository and hopefully preserved into the future. We're really starting to see a carrot and stick approach here. There's a lot of benefits to sharing research data, increased recognition and promotion for your research. And we're also seeing granting agencies also starting to require data set deposit and even journals as well. As a result, we're really starting to see more data sets being deposited into research data repositories. And we're also seeing an increased recognition of the importance of that work, maximizing the benefits of open science and the goals of research transparency and reproducibility. I'm sure many of you have heard of the FAIR principles. They stand for findable, accessible, interoperable, and reusable. These were really developed to encourage that data sets that are collected across disciplines meet specific standards to improve the discovery of data and also its reuse. Data deposit is not sufficient, though. So we see that long-term preservation is not specifically incorporated into any of these principles. But they really are fundamental to the continued ability to be able to discover and access and reuse research data into the future. So if we bring digital preservation into this concept of research data management, this is where we're starting to look at what is the role of research repositories. So digital preservation involves a series of managed activities. So this is not just putting data somewhere and forgetting about it. It's really an ongoing process to ensure that we have continued access to these digital materials for as long as necessary. And there are a number of risks to digital objects. I've listed a few here, but really the two I'll be focusing on today involve format obsolescence. So this is the inability to open file formats into the future. Not sure how many of you have used some old formats like WordPerfect, for example, from the 90s. So how can we make sure that we're able to access that data? Well, digital preservation could do things like monitor these formats that are at risk and then maybe attempt to migrate those formats into more open or non-proprietary formats and things like that. Another is loss of provenance. So this is the lack of information about a digital object. So what's the source? Is this an authentic source? Are there IP restrictions or things that could prevent us from using it and things like that? So for digital preservation activities, we might want to make sure we extract a lot of metadata or create metadata and documentation to better understand and even package that information so that it comes together into the future. So again, what is the role of research data repositories in these kind of efforts? So look at Borealis today as sort of like a case study and try to show you some of the things that we've been doing to try to support institutions in preserving research data. So Borealis is a Canadian research data repository. It's supported by academic libraries and has funding from the Digital Research Alliance of Canada. It's built on open source Dataverse repository software. It's hosted at Scholars Portal and the University of Toronto Libraries. And every data set gets a digital object identifier or DOI. So those data sets are indexed in search places like DataCite, Google, and Lunaris, which is a national discovery platform. And we have over 75 Canadian institutions who are now participating and subscribing to the service, which is so exciting to see it growing so much. So on the left, you can see this is sort of the structure of the repository. So Borealis is the technical infrastructure, and then each institution has a collection that can contain data sets and sub-collections and things like that. And what's really important here is that libraries or other bodies on campus are the ones that are administering these spaces for their researchers. They are the ones that are setting the policies, supporting researchers in depositing, curating the data, making those appraisal decisions and things like that. So on the right, you can see an example of an institutional collection at the University of Victoria, and you can see they describe their services, they have links to resources and things like that. So it's a sort of a shared infrastructure, but the repository is home for all of these different collections, and they have different policies perhaps or things happening there locally. So this is sort of a classic look at preservation. It's called the three-legged stool of digital preservation that was put forward by Anne Kenny and Nancy McGovern. So the three legs are technology, organization, and resources. And I've kind of situated Borealis under the technology leg, if you will, because we're really trying to focus on that first and foremost. We provide the storage and backup, the repository system, tools and security, and things like that. Really, institutions have to be involved in all legs of the stool. I've put them under the other two for organization, so things like policy and strategy, procedures, things like that, as well as resources like costing, funding, sustainability, staff skills, and things like that. And if any of these legs are wobbly or missing, you can see that the risks for digital preservation are just much more extreme for sure. And we're trying to support in helping institutions with the other legs as well, but we can't stand in for these things. It has to be complementing what the institutions are doing. So I just wanted to touch on some of the ways that Borealis is supporting preservation activities. There are some things that just come out of the box with the Dataverse software. So all files, for example, get a checksum, which is a unique value that represents the bit stream of the file and helps us determine if there are any changes in fixity over time, or is there corruption happening of the files. There also is file format identification done through a number of ways, and also file level metadata, so things like the size and the file path and things like that. For tabular files, there's some additional processing that's being done. There's an additional checksum, UNF, which helps to look at the semantic content of the file. What's really cool is there's format normalization that's happening. So the Dataverse actually converts these tabular files into a tab delimited text file, which is open and non-proprietary. So it helps to make sure users can open things into the future. Not everyone can afford an SPSS software license and things like that. And also extracts variable level metadata into the Data Documentation Initiative standard, and then you can actually export a code book and things like that. There are also additional actions that can happen that the institution may support depositors with. So additional data set level metadata, file level metadata, and you can also upload documentation like README files and code books and things like that. They give the really important context about these files. So in 2022, we released the Borealis Preservation Plan that outlined kind of the roles and responsibilities and the actions that would be happening in the repository. So level 1 is just ensuring a minimal level of fixity assurance. It's also called bit level preservation for all uploaded files. We have outlined the safe storage, and I'll talk more about that in a moment. And then maintaining all of those features I just mentioned that support preservation. There's also a level 2, and what this is that we want to support institutions who want to do additional preservation work. So that could be exporting independent packages of these data sets and doing additional preservation processing, and then separate storage and ongoing management into the future. So I'll talk about each of these. So first is that safe storage. All the data files are stored on the Ontario Library Research Cloud. This is a private cloud storage network that Scholars Portal manages. And so files are automatically replicated across 3 data center nodes in Ontario. And there's also daily backup of all the files using a storage manager. So if you see in this diagram, we've got the files stored in the OLRC, and then we have the storage manager, and it retains several versions of files and then backs up on-site and off-site. So just because Dataverse creates a checksum doesn't mean that it's actually doing anything with that checksum. So we needed to develop a monthly process to validate all of the files in Borealis. So what happens is we generate a list of data sets that need validation. So these are all the user uploaded files. And then we use the Dataverse API to validate each checksum against the Dataverse record. And then we created a database that logs all of the successes and failures, the date, the error type, and things like that. So this was developed by two of our programmers. It uses Python, Dataverse API, and then there's an SQL database, and it uses Jenkins as an automation server. So what we do every month is we have to review this report and then determine what we should do if there are issues, if there are some checksum mismatches. So what we do is look in the backup. If there's a backup that exists, what we can do is confirm that the checksums match. We confirm the file details, and then the script actually replaces the corrupted file on the back end. And also we add provenance information to explain what we've been doing as part of this remediation process. Now, if there isn't a backup, what do? We have to contact the institutional administrator to determine if they have a backup, and sometimes they need to reach out to researchers as well. So this can be a really long process going back and forth to try to find these backups. If we do get a backup, we do the same process as I just mentioned. But then we had to come up with a process again if there aren't any backups. So what we ended up doing is deciding to create a metadata record of the files that were deposited. And we export that as a JSON. That JSON gets added to the data set, and we add additional provenance information, and then we delete the corrupted files on the back end. So the first time we ran the script was back in December of 2021. At that time, we checked over 200,000 files, and this is about 8 or 9 years of files that were deposited and never been checked before. And we found 228 invalid files over 21 data sets. Now, this seemed like a lot to us, but it actually only represents 0.1% of the files in the repository. So we had a lot of work to do, and we're still actually remediating those files. We're down to 32, so we're making progress for sure. But you can see it does take a lot of work behind the scenes. Every month it runs. So the most recent one was October. We checked over 500,000 files. It took over 50 hours. And there were no new invalid files. So it's really great to see that the process is working now. So I have a couple minutes. I'll just describe level 2, which is really important. It's kind of going beyond this bit level preservation. Bit level is great. It's doing a lot. You can see it's still a lot of work. It's not just setting and forgetting, but it's not enough to ensure that the files are going to be usable into the future. So what we do is we offer 2 technical workflows to support institutions. And really, institutions are best positioned to do this kind of work. They're the ones that are doing the appraisal, the curation. They're the ones making decisions based on their policies. So we're just trying to give them some technical support in order for them to undertake this work. So the first one is a Bagot export. So they can request data sets, and we export them in this Bagot compliant package. They're like archival packages that include all the metadata and files and things like that. We have developed a new script to batch export data sets as bags, and then we deliver it to the institution. So that's one option. The other is Archivematica integration. This Archivematica is sort of like a really robust preservation system for processing digital objects. And Scholars Portal actually sponsored the integration a few years ago now. What it allows you to do is, as an Archivematica user, you can query a Dataverse installation, pull data sets into the local storage there. You can do additional preservation processing and then transfer it to a separate storage location. Level 2 in practice. What we're finding from our perspective is so far there's been really low uptake on these level 2 services. I pulled in some results from a recent survey that we did of Borealis collection administrators that I have been working on with Elisa Maud as well. We're finding that additional preservation processing was only offered by a very small number of institutions, less than 7%, and a very small proportion, about 4%, even had a preservation policy at all that they're working from. But many of the comments suggested that they're really relying on Borealis as the preservation, as the backup. But we know a backup is not enough for preservation. So we're really trying to see how we can support institutions in other ways. So just some discussion thoughts. I don't have all the answers. It really is a challenging endeavor. There's so much complexity around research data. It's heterogeneous. There can be sensitivities with the data. There can be lots of different things to consider. There's complexity around the roles of like, what is the role of the repository versus the institution versus the researcher? We're finding that coordinating RDM services and programs around digital preservation are really in the early stages at institutions. And really, we're seeing that there needs to be additional funding, training, capacity to be able to do this work. And maybe there's an opportunity to envision some national models where we could support institutions in doing this work more collaboratively, but that remains to be seen. And just quickly, some ongoing work we're doing at Borealis. We're trying to improve documentation and resources to support institutions. We're also helping the Preservation Expert Group with the Digital Research Alliance in developing resources to help institutions with Core Trust Seal certification. And this involves a description and policies and documentations around preservation. And we're also trying to come up with a new report for institutions that would better explain the kinds of file formats that are in data sets in their collections, so they could better monitor, if there are file formats that are risky or things like that. So I just wanted to say a big thank you to the Scholars Portal team, especially the programmers, Victoria and Carlos. Amber Leahy's the Borealis Service Director, has been really instrumental in this work. Grant Hurley and, of course, Julie Shee as well. It's a really collaborative team, and look forward to your questions. Thanks so much for your attention. Any questions? Are there any questions?
Thank you. Great talk. Just a quick question about the files that failed the fixity check. Do you know why they failed? Like what caused that failure?
Yeah, so a lot of them were 0-byte files. So we think that it was probably just what happens during upload. So what happens when you upload is it goes into like a temp space while the data set's being ingested and things like that. And then it gets moved over to permanent storage. So probably something happened. So like a checksum was taken and then it moved and then it failed. And it could have happened at any point because it never, before that, it had never been checked, right? The fixity. So, I mean, there are several different storage backends that have happened during that time. So it could have happened in the migration, could happen in the upload. So it's really hard to tell. But now we have this robust system. We can immediately check to see if we have something in backup if that happens again. The safe storage with the OLRC as well mitigates a lot of those issues. So we're just kind of dealing with the legacy of like the older system and trying to move forward. But we've had really good feedback from the institutional administrators that we've been working with. I was worried when you get an email like you have all these files that have been corrupted, but they've just been so helpful and wonderful and grateful that we're doing this work on their behalf. So we're just trying to get through those last 32 files, which is tough, but we'll get there. Yeah.
For sure. Yeah. No, it was 32, like they're part of the original 200 or so that were.
Yes, exactly. Yeah. We're still working through that original 200. Yeah.
Okay, cool. Thank you.